let's continue our lecture. The second classification of amino acid is according to the polarity of the side chain. What the meaning of polarity? It's the ability to form a hydrogen bond with water. Polarity. Amino acids are classified into hydrophilic, means it loves water or likes water. Philic means loves or like. This means that it can form bond with water molecules. And hydrophobic, phobic means don't like or don't love. So they can't form bonds with water molecules. So according to polarity of the side chain, amino acids are classified into hydrophilic and hydrophobic. Hydrophilic amino acids it contain charged amino acids اللي هم عليهم charge either negative or positive. فاكرين لما قلنا الاسيدك amino acids have negative charge because of the extra carboxylic group اللي هم glutamate and aspartate, while basic amino acid have positive charge due to the extra amino group, and there is polar uncharged amino acids. Let's know the hydrophilic amino acids. Polar hydrophilic amino acids mean that they have polar group in the side chain that can participate in the hydrogen bond formation with water. They are containing a polar uncharged side chain, have no charge, which contain hydroxy amino acid, sulfur containing amino acids, and amide amino acids اللي هما serine, threonine, tyrosine دول الهيدروكسي amino acids, cysteine sulfur containing amino acids, and asparagine glutamine amide containing amino acids. They are polar uncharged, they have no charge, okay? And there is the charged side chain, which we have mentioned. They are positively charged or negatively charged. Positively charged amino acid, they are the basic amino acid, contain extra amino group having positive charge, including glycine, arginine, and histidine. And negatively charged amino acids, they are the acidic amino acids containing extra carboxylic group, have negative charge, contain glutamic acid and aspartic acid اللي هما الglutamate and aspartate. Those are the hydrophilic amino acids. The hydrophobic non-polar amino acids, they are the rest of amino acids which can't form hydrogen bonds or can participate in formation of the hydrogen bond with water. They are the rest of amino acids: alanine, isoleucine, methionine, tryptophan, phenylalanine, valine, leucine, tyrosine, proline, and glycine. The third classification of amino acids based on the nutritional requirement, or it's called biological classification, whether I need to take this amino acid in diet or my body can synthesize this amino acid. They are classified into essential, semi-essential, and non-essential. Essential, from its name, I must take it in my diet, so my body can't form this amino acid. So if I didn't take this amino acid in the diet, which usually animal source, there is deficiency in this amino acid and can cause problems. So essential amino acids must be taken in our diet because our body can synthesize them. It includes valine, isoleucine, leucine, lysine, arginine, methionine, threonine, tryptophan, phenylalanine, and histidine. There is a mnemonic sentence to remember essential amino acid. It's private Tim Hall. Private Tim Hall. El P for phenylalanine, V for valine, T for threonine, T of the tryptophan, I isoleucine, M methionine, Hal histidine, leucine, and lysine. This is for easy remembering of essential amino acid. It's private Tim Hall. Semi-essential amino acids. What's the meaning of semi-essential? They can be synthesized in our body but in less rate than non-essential. So I need extra amount of them in certain conditions like growth, repair, and pregnancy. So I need to take them in diet in certain conditions like growth, repair, and pregnancy. This include arginine and histidine. Arginine and histidine are semi-essential amino acids. Non-essential amino acids, they are the rest of amino acids which are other than essential. They can be synthesized in our body, and their absence in our diet cannot affect the growth because our body can synthesize them. This is a list of essential and non-essential amino acids, and remember the mnemonic. For essential, it's private Tim Hall. There are 10 essential amino acids, including 2 semi-essential, arginine and histidine, and the rest of other amino acids other than essential, also 10 non-essential amino acids. The biological value of protein. The protein have high biological value if it contains one or more essential amino acids. It have low biological value if it has no or low number of essential amino acids. This means that it have high biological value or low. Most of the animal sources containing is a complete source of protein and containing all essential amino acids, but vegetable source have lack in one or more of the essential amino acids. So animal sources is high biological value, and vegetable sources is low biological value of protein. So high biological value protein contain all essential amino acids. It's usually animal source. Essential amino acids are needed to be in our diet because our body can synthesize them, and this affect growth and repair and pregnancy. Low biological value protein, they don't contain all essential amino acids and usually come from vegetables. The last classification of amino acid, which is based on the metabolic fate. What the meaning of the metabolic fate? It's the fate of the carbon skeleton of amino acids. At the end of their function and degradation of the protein amino acids, the carbon skeleton of it must be degraded and metabolized either into glucose to produce glucose. We must get use of it either, so it's called glucogenic, or forming ketone body, so it's called ketogenic. It forms acetyl CoA or ketone bodies, or can form both glucose and ketone bodies, so they are called both glucogenic and ketogenic. Again, the last classification of amino acid according to their metabolic fate. What the meaning of the metabolic fate? It's the fate of the carbon skeleton of amino acid either enter in glucose formation, so it's called glucogenic amino acids, or pure glucogenic amino acids forming glucose, or form ketone body or acetyl CoA, so they are called ketogenic, pure ketogenic, or can form both glucose and ketone bodies, so they are called mixed, both glucogenic and ketogenic. Let's know them. Pure ketogenic amino acids are both have L, leucine and lysine. Leucine and lysine, they are pure ketogenic. The mixed amino acids, glucogenic and ketogenic, are isolysine, tyrosine, phenylalanine, and tryptophan. Those three are the aromatic amino acids. Do you remember? Tyrosine, phenylalanine, tryptophan, and isoleucine. 4 amino acids which are mixed, both glucogenic and ketogenic. The pure glucogenic, which at the end converted into glucose, the remaining amino acids, all of them are glucogenic. This is the last classification of amino acids. Let's have practice. Which amino acid isn't basic? It's asparagine, it's amide containing and not basic. Which of the following isn't an essential amino acid? It's alanine. An aromatic amino acid, tyrosine. Ketogenic amino acid, amino acid both L, it's leucine. The last part of our lecture is property of amino acids. Amino acids are soluble in polar solvent. They are colorless, have amphoteric property, and we will know what the meaning of amphoteric property, and isoelectric point, and they have buffering activity. The buffering activity, you will take it in details in physiology. So amino acids are soluble in polar solvents, colorless, have amphoteric property and isoelectric point. They have buffering activity. Solubility, they are insoluble in non-polar solvent and soluble in polar solvents. What the meaning of polar solvents? Like water and alcohol, they have charged group. Okay, they have a charged group, so the amino acids also have carboxylic group negatively charged, amino group positively charged, and can be soluble and can be ionized in those polar solvents. Amino acids are colorless. They have no color, so they don't absorb visible light, but aromatic amino acid can absorb lights, and this means it can give us a color in spectrophotometer, and you will take examples in the lab, inshallah. Amphoteric property. What the meaning of amphoteric property? It's the ability of the amino acid to behave as an acid, its proton donor, or a base, proton acceptor. Do you remember at the beginning of the lecture we did say the meaning of acid? It's proton donor and carrying negative charge, like the carboxylic group. It can give its hydrogen, proton donor, and carry negative charge. And what the meaning of base? It's proton acceptor and can carry positive charge, like the amino group. So amino acids have amphoteric property. They have the ability to act like acid due to presence of the carboxylic group, and they have the ability to act like bases as they have the amino group, so they can behave like proton donor or proton acceptor. This depends on the media or the pH of the solution that the amino acid presents. If the amino acid present in alkaline media means low hydrogen concentration, and this means that the carboxylic group can donate proton. There is low hydrogen concentration, so the carboxylic group tends to give its proton, so this will carry negative charge, and the amino acid will act like acid and will have negative charge, and on the electric field it will migrate to the anode. Anode means it's the positive electrode. Any electric field have positive electrode and negative electrode. You all know this. When the electric current pass in any solution which is ionized, and its ions have charge either positive or negative, always the positive charged molecules or ions will migrate to the cathode, which is the negative electrode, and the negative charged ions will migrate to the anode, which is the positive electrode. So to remember this, remember alkaline means low hydrogen concentration, so the carboxylic group tend to donate proton carrying negative charge, so on electric field it will migrate to the anode, which is the positive electrode. In acidic media it's the contrast. In acidic media it have high hydrogen concentration, so the amino group tend to accept proton, and the amino acid will carry positive charge, become positively charged ion, migrate to the cathode, which is the negative electrode. Again, you can remember acidic contains C, and cathode. Alkaline A, anode. So in alkaline media carry negative charge and migrate to anode. In acidic media have high hydrogen concentration, which make the amino group of the amino acid accept proton, carry positive charge, and migrate to the cathode, which is the negative electrode. This is the amphoteric property of the amino acid. It can act as acid or as a base, and this depends on the media in which the amino acid present. So in acidic environment, so the amino group will accept proton, and all amino acid gain positive charge, and this will migrate to positive charge, and this will migrate to the cathode. It's the negative electrode. In alkaline media, the carboxylic group tend to donate proton, and the amino acid will carry negative charge and will migrate to anode. In neutral environment, the amino acid will contain or will carry both positive and negative charge, which are equal, and it will be neutral, and this is called the isoelectric point. Isoelectric point. What's the meaning of isoelectric point? It's a specific pH at which the amino acid carry zero net charge. Zero net charge, it means that the sum of charges on the amino acids is zero. Number of positive charges equal number of negative charges. So the amino acid will be electrically neutral and can be precipitated. It doesn't move on the electrical field. It doesn't move as it's neutral. It won't move to the cathode and won't move to the anode, and this help in precipitation and separation of amino acids. So again, what the meaning of isoelectric point? It's a specific pH at which the amino acid carry zero net charge, means that the positive charges equal the negative charges, so it's neutral and can't move to either the anode or cathode and can be precipitated and separated. In this condition, this amino acid is called Zwitterion or Zwitter. Zwitter, it's German, so it's called Zwitterion. What the meaning of Zwitterions? It's dipolar ions, amino acids, when they are electrically neutral, having equal positive and equal negative charges. So it's called Zwitterions. In the isoelectric pH, this is the end of our lecture. Thanks.